Hey guys, welcome back. Today we're going to talk about parallel and perpendicular lines. So let's look at our first example that we have here. We have two lines. Let's add the little arrows here. I don't want to have line segments. If you look at line A, you notice that it crosses right here. It crosses the y-axis at 6. So your y-intercept or your b value would be 6. So think about the equation of a line being in the form of y equals mx plus b. All right, so our b is 6 because we cross the y-axis at 6. And our slope here, if I look at these 2 points, I rise 2 and I run 1. So 2 over 1 would be 2. So the equation of line A would be y is equal to 2x plus 6. Okay, and now if I looked at line B, I'm going to cross the y-axis at -4. So our b value is -4. And our slope here, if I rise 2 and I run 1, again our slope is 2. So the equation of that second line is y is equal to 2x minus 4. Okay, so let's look next at the next example here. Okay, I've got two horizontal lines. All right, when we have a horizontal line, we think of HOI. So horizontal line has a 0 slope. The equation of line A would be y is equal to, and we're crossing at 2, 3. So y is equal to 3 for line A. And then line B, our equation would be y is equal to -2. Okay, all right, again, the slope in both cases would be 0. All right, looking at our third example here. Okay, looking at line A, we cross at -4, so our y-intercept is going to be a -4. And our slope is going to be, we rise 1 and go left 1, so our slope here is a -1. So for line A, the equation of line A would be y is equal to -x minus 4. And then with line B, our y-intercept is at 3, so our b is equal to 3. And our slope here, again, we would go down 1 to the right 1, so we would get a -1 over 1, which is -1. So the equation here would be y is equal to -x, equal to -x plus 3. So if you notice in all three cases, we have parallel lines, okay? And the parallel lines, if you notice between the equation of both lines, the slopes are always the same, okay? So in the first case, our slope here was 2. Okay, the second example, our slope here was 0. And here, our slope is equal to -1. Okay, so we can conclude that parallel lines have the same slope. Have the same slope. All right, so now let's take a look at perpendicular lines. Okay, perpendicular lines meet at a 90-degree angle. So we're going to look at our different lines again. Okay, so let me just shift this over a little bit, make it bigger. Okay, whoops. Okay, whoops. Let's line this up. Okay, that's a little bit better. Okay, so if I look at the, that means my little arrows are off. Okay, but now if we look at the first line, line A, okay, my y-intercept here, I'm crossing, okay, right here. So my y-intercept is at 0. Okay, and my slope is going to be, I'm going to go, let's use this point right here. I'm going to go down 1 to the right 2, so I've got a -1/2 slope. So the equation of that line would be y is equal to -1/2 x. All right, now looking at line B crosses right here, so our y-intercept is at 1. And our slope now, if I go up 2 to the right 1, so my slope is 2 over 1, which is 2. So the equation of that line B would be y is equal to 2x plus 1. Okay, so now let's look at the next example that we have. Okay, line A. Okay, line A, my y-intercept here is going to be at 0, so my b is 0. And my slope, I'm going to go up 1 to the 1, 2, 3. So I'm going to go up 1 to the left 3, so my slope is going to be -1/3. Okay, so the equation of line A would be y is equal to -1/3 x plus 0, but we don't write the plus 0, we just write it as 1/3 x, or -1/3 x. Now looking at line B, all right, so I add my little arrows. So line B, I am crossing the y-axis right here at -4, so my b is equal to -4. And my slope, I'm going to go up 1, 2, 3 over 1. So my slope is going to be a positive 3. Okay, so the equation of that second line is y is equal to 3x minus 4. Okay, the third example we have for perpendicular lines. Okay, if I look at line A, my y-intercept here is going to be right here. So that's going to be at 3. And my slope is going to be, we're going to go 1, 2, 3, 4 over 1. So my slope is negative 4. Okay, so line A, the equation is y is equal to negative 4x plus 3. All right, and then looking at B, I'm going to cross right here at negative 3. So my y-intercept, or B, is negative 3. And my slope, I'm going to rise 1, and then I go over 1, 2, 3, 4. So my slope here is going to be positive 1/4. So the equation of that second line is y is equal to 1/4 x minus 3. Okay, we had a little bit of okay, back from the technical difficulty. Okay, what we notice about the equation, so the slope here is negative 1/2, and let's make sure we're on the screen. Okay, so the slope for the first line is negative 1/2, and then the second line, the slope is 2. Okay, if you notice, the slopes of perpendicular lines are the negative reciprocal. So they are the negative reciprocal. And the negative, or meaning the opposite, okay, reciprocal. And what a reciprocal is, as a reminder, okay, so if I had the whole number 3, the reciprocal would just be, I take 3 over 1 and I'd flip it, and it would be 1/3. The negative reciprocal would just be the negative 1/3. Okay, so if I had the number, if I had a fraction 2/3, my reciprocal would be 3/2. And my negative reciprocal would be negative 3/2. Okay, so perpendicular lines have negative reciprocal slopes. Okay, so if two non-vertical lines have the same slope, then they are parallel. Okay, and the symbol that we use for parallel lines, okay, let's write in the symbol, looks like this, two lines that are parallel. Okay, so the example that we have is if we have line A is y is equal to 3x plus 4, and then we have line B is y is equal to 3x minus 2, we can say that line A is parallel to line B. Okay, so let's see, we're a little off with our lining up, so let's try to fix this for a minute here. Okay, let's try to see this, scooch on over a little bit. My recording isn't very nice today. Okay, so looking at the second here, if two non-vertical lines have slopes that are negative reciprocals, then they are perpendicular. Okay, so in my example, if I had line A was y is equal to 2x minus 1, and then maybe I had line B, and it would be y is equal to negative 1/2 x plus 4. Okay, the symbol for perpendicular is going to look like an upside down T. So we can say that line A is perpendicular to line B. Okay, so our next example that we're looking at says write an equation of the line that passes through this point, negative 3, negative 5, and is parallel to y equals 3x minus 1. Well, looking at 3x minus 1, we can determine that the slope is equal to 3. Okay, so if it's parallel, the slope is still going to be 3. So our parallel slope is still 3. So now we're just going to use point slope form, excuse me. Y minus y of 1 equals m times x minus x of 1. So y plus 5 is going to be equal to our slope, 3, times x plus 3. All right, because we're subtracting a negative, so it becomes plus. So after we distribute, we get 3x plus 9, and then we subtract 5 from both sides. So y is equal to 3x plus 4. So that's the equation of the new line that passes through the point negative 3, negative 5, and is parallel to the line here. And you could put both of those lines in Desmos and verify that they are indeed parallel. All right, so if you want, you can pause and try number 2, but I'll do it here. Here my slope is negative 1. And since it's parallel, it's going to be the same slope. So when I do point slope form, y minus 11 equals negative 1 times x plus 2. Y minus 11 is equal to negative x minus 2. And then when I add 11 to both sides, I get negative x plus 9. All right, let's try number 3. Number 3, we're actually going to write one that's perpendicular. So when I look at this slope, I pull out that the slope is 2, but our perpendicular slope is going to be the negative reciprocal. So it's going to be negative 1/2. Now you need to be really careful, and you're going to use the new slope when you do point slope form. So y plus 5 is equal to negative 1/2 times x minus 4. Okay, notice I'm using the new slope with point slope form. After I distribute it, I get negative 1/2 x, and 1/2 times 4 is going to be positive 2. Okay, after I subtract 5 from both sides, I end up with y is equal to negative 1/2 x minus 3. Alrighty, looking at number 4. Why don't you try number 4, maybe pause it and try it, but again, we're perpendicular, so our slope here, we're lucky these are all in slope-intercept form, so it makes it easy to find the slope. And the perpendicular slope is going to be negative 1/4. We use that new slope in point slope form. Y minus 3 is equal to negative 1/4 times x minus 4. All right, after I distribute, I get negative 1/4 x plus 1. And then I'm going to add 3 to both sides. Okay, so y is going to be equal to negative 1/4 x plus 4. Okay, so now it says determine which lines, if in each set, are, if any, are parallel or perpendicular. So in order to do that, we need to determine the slope for each line. So sometimes it's easy, and the slope for line A is really easy. It just falls out. Y equals, slope would equal 5 because we want to get this, our equation in slope-intercept form. Line B, we're going to move it around a little bit to get it into slope-intercept form. So 5y would be equal to negative x plus 2, and then we have to divide by 5. So when we do that, y is actually equal to negative 1/5 x plus 2/5. Okay, so when we do that, our slope can fall out as negative 1/5. Okay, in line C, I'm going to divide both sides by negative 10. So y is equal to negative 1/5 x. So our slope here is negative 1/5. Okay, so just starting out, it looks like line B and line C have the same slope, so we can easily say that line B is parallel to line C because they have the same slope. Okay, if you look at line A is actually going to be perpendicular to line B, okay, because they have negative reciprocal slopes, and line A is also perpendicular to line C. All right, so you can try the next one and then check your answer. Okay, here my slope, when I pull it out, my slope is going to be equal to 3/5. Okay, when I divide by 5 here, I've got y is equal to 3/5 x minus 2/5. So my slope here is also 3/5. All right, and then on this one, negative 6y is equal to negative 10x minus 4. And then when I divide by negative 6, I get y is equal to 10/6 is going to be 5/3 positive, 5/3 x, and negative 6 would be plus 2/3. Okay, so our slope here is 5/3. So we can say that line A and line B, since they're the same, are parallel. So line A has the same slope as line B, so line A is parallel to line B. Okay, now I do see that line C is the reciprocal of a line, reciprocal slope, but it is not the negative reciprocal. So we're just going to keep the answer at line A is parallel to line B. Okay, so 7, if we want to figure out the slope, be careful, we're just looking for the slope. So in order for it to be parallel, it needs to be the same slope, so we want to put it in slope-intercept form. Negative 3y equals negative 3x plus 12. And then we divide by negative 3. Y is equal to x minus 4. So once we do that, jumps right out that our slope is, oops, it went away again. Our slope is 1. Okay. All right, so for purposes of time, I want you to try the other ones and compare them to the key, but I do want to show you, for example, we're going to go to the graphing ones. So I want you to go to number 15, all right, and we're going to give that a try here. All right, just for purposes of time, I don't want it to take too long. Okay, so if we look at number 15, okay, let's see. It says graph each line. Oops, a little shifted here. Okay, let's go to this one. Okay, a little out of the box here. Okay, graph each line and write the final equation in slope-intercept form. So what line is parallel to y equals 3x plus 1? So when you do these problems, okay, you want to first identify, in this case, it's going to be parallel. So here our slope is 3, so the parallel slope is also going to be 3. All right, if we graphed y equals 3x plus 1, we start at our y-intercept, 1, 2, 3 over 1, or go down 3 over 1. Okay, so there's the graph of the first line. All right, we're looking for the equation of the line that passes through negative 1, 2, and it's parallel. Now, we don't want to just draw a parallel line. Okay, we're going to have a line that goes through this point. So we're going to use point-slope form. This is so frustrating today. Okay, so we're going to say y minus 2 is equal to 3 times x plus 1. We're going to distribute y minus 2 is equal to 3x plus 3, and y is equal to 3x plus 5. Okay, so there's the equation of the second line. All right, so we get to our y-intercept of 1, 2, 3, 4, 5, and our slope is 3, 1, 2, 3 over 1, 1, 2, 3 over 1. So as you can see, we are parallel to that line. Okay, so I want you to try 16 and compare to the answer key that's on the website. Okay, but I am going to do number 17 with you right now because it's an example where they are perpendicular. So what line is perpendicular to y equals 2/3 x minus 1? So here our slope is 2/3. So our perpendicular slope is going to be negative 3/2. We take the negative reciprocal. Okay, so we're going to go back and graph this first one. Okay, 2/3 x minus 1, we start at the y-intercept of negative 1, and rise 2, run 3. Rise 2, run 3, we're off the graph, that's okay. Go down 2 over 3. Okay, so there's the graph of the first line. Okay, we want it to go through the point negative 2, 2. Okay, and we don't want to just draw a line perpendicular. We want to make sure it actually works out. So we've got our perpendicular slope that we're going to use is negative 3/2, and we're going to use this point negative 2, 2. So y minus 2 is going to be equal to negative 3/2 times x plus 2. All right, y minus 2 is equal to negative 3/2 x minus 6/2, so minus 3. And then when we add 2 to both sides, okay, we end up with y is equal to negative 3/2 x minus 1. Okay, so we start at negative 1, and then we go up 3, 1, 2, 3 over 2. Up 3 over 2. Okay, right here. All right, so there's the graph of that second line. Notice they are perpendicular. Okay, so I want you guys to try the problems that we skipped and check it out with what we have. And again, I apologize for the technical difficulties. Hope this helped. Bye.